is just another way to solve oblique triangles. There are some times that you can't use law of sines. Like, what if they only gave you the three sides of a triangle? Can you use law of cosines for that?
Yeah.
Law of sines?
No.
You can't use law of sines if you don't have one angle and the side across from it. So there are times that law of sines doesn't work. So then we have law of cosines. Law of cosines is a little bit more tedious than law of sines. So that's why we use law of sines first, and then law of cosines is like, okay, that didn't work. We have to use law of cosines. For cases where law of sines fails, we have law of cosines. So you can write this for any side or any angle, which means we can write this a ton of ways, but I want you to see what's happening before I write them all. That's why I only wrote it one way. If you want to solve for A, for law of cosines, you can say that A squared equals the sum of the other two sides squared. So A squared equals B squared plus C squared minus 2 times the other two sides times the cosine of that angle. Whew. What do you think B squared equals?
C squared. Minus 2bc cosine A minus A squared.
No. No, I don't want that. Like,
Oh, no, wait.
what if I knew? Yeah, like, here's the issue with law of cosines. That, like, what if they only gave me angle A? Then that's how I know how to do this one. But what if they gave me angle B? Then you have to use a formula with angle B in it. So B squared is going to equal the sum of which two sides, you think? Right? Each side is going to equal the sum of the other two sides minus 2 times the other two sides times the cosine of whatever this is. This angle will be the same over here. So think about that. What is B squared going to equal then? B squared is going to equal
C squared plus A squared plus C squared.
Doesn't matter what order you say that in. Minus, it's always going to have a 2, but now instead of B and C, it's going to be AC, and it's going to be cosine of B. Whatever this side is, this angle will be the same. Which means we really can write this 3 ways, but I don't feel like you have to memorize 3 formulas, because you just have to know what goes together. So we could say that C squared, if I knew angle C squared is going to be equal to the sum of the other two sides. It's going to be A and B, right? A squared plus B squared minus 2 times A times B cosine C. Yes? They also show that you could solve for the angles. I don't think that, to me, it doesn't make sense to memorize another formula when you could just solve it, right? So let's just skip that round. That's not very good plan. Just know this.
Recording.
I am. Should we draw a picture? Everyone just complained that my picture is not to scale.
I think it's definitely not scale 16 is not one.
I don't care. My triangles always look the same. You. I just said you. I didn't mean you. Like I didn't say Ariel's gonna complain.
I really thought you said Ariel. I was like, I said Ariel's gonna complain.
Then you all were. I don't know. I didn't say your name, I promise.
Okay, I was like, I don't think I can believe it.
So, on a test, I'm not going to say use law of sines or law of cosines because the triangle only lets you use one. You cannot set up law of sines here because we don't know any angles. So we have to use law of cosines, which means we can really use any of those equations I gave you, right? Let's just start with the first one. A squared equals B squared plus C squared minus 2BC cosine of A. If you wanted, could we solve for cosine of A before we started plugging all the numbers in? You see what I'm saying? Like, if you didn't want to deal with this equation, Could we get cosine of A by itself and then just plug everything in that way? I don't care which way you do it. I don't know what makes more sense. Do we want to do the algebra with the letters, or do you want to do the algebra with the numbers? I think numbers both make more sense. But we could get cosine by itself if you want to subtract that, divide by that, right? But let's just plug in numbers. Make sure you plug the numbers in the right spot. It really stinks when you mess that up. Maybe because I've done it a few times. B is 16, C is 29, cosine of A.
That's what I got.
Who needs calculator? Dylan? You have one? I guess I don't have a calculator. I think it's cooler outside.
Got it.
So be careful with your math here, okay? This is multiplied by cosine of A, which means you can't just type this plus this minus all this on your calculator. Yes? So, I don't know how much work we're going to show here, but I tend to just not show what we're drawing out here. 576 equals 16 squared plus 29 squared, which is 1097. And then 2 times 16 times 29 is minus 928 cosine of A. So I just want to caution you, because what happens every time, people take 1097 minus 928. You cannot do that because this cosine is stuck with that. Which means just like if that would have just say 928x, to solve for it, you're going to subtract this and then divide this. Right? Just making sure. I don't tend to show this stuff very well. I kind of just automatically on my calculator take 24 squared minus 16 squared minus 29 squared, which is what I would get if I subtract that over. And I would get negative 521. So that's going to be 521 over 928 equals cosine of A. And then what should I do to find A?
First.
Yeah. You're with me today, children?
57.2.
521 divided by 928. You get, I got 55.8.
57.1.
Oh, I think I did inverse sine. Inverse cosine, not long sines anymore. No, I got 55.8.
I got 57 point. Look, I got. What did you get when you divided those two?
Don't divide them. Keep it 521 over
I'm
928.
dividing them.
Then you get the wrong answer.
No.
I got 55.
That's what I got too.
Oh,
That's what I
that's
said the first time.
I was like, switch first cosine.
So, if you're going to divide these and write it as a decimal, you have to. That's where you have to write down all the decimals. You can't just round it off because it really will change the value.
I read them all down.
And did you do inverse cosine?
Yeah, look. Okay, we're only like 2 off.
You
What
said
you got?
57.
That's 2 off of what you got.
That's a lot
I wrote
off.
down all the decimals like that.
Not 503. It's 521.
Why did I get 33?
Right?
Ollie just called me dumb. You're Italian.
Anyone else need help? Calculator help? My advice is, I just leave that as a fraction. Like I do inverse cosine and I just type in 521 divided by 928 and I don't have to write all those decimals down. Whew, that was a lot of work, right?
Yeah, but
Yes.
I guess why is it inverse cosine?
Because if you're solving for an angle, the only way to get rid of cosine is to do inverse cosine. Like anytime we solve for an angle. So here's a couple nice things. One, this is not angle side side, yes? It's side side side, which means you don't have to worry about should there be a second triangle, because for side 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 there's only one triangle. So that's nice. So we got that angle A was 55.8 degrees. We could just do law of cosines again to find another angle. Yes? That's a lot of work, right?
Yeah, it is.
Doesn't that seem like a lot of work? Way more work than law of sines?
I thought you said sine. Sorry.
Sines.
So now that we have this, we want to go back to law of sines, but you got to be really careful because if you pick the wrong side to work with first, that darn angle side can come back to get us. So, so here's the rule. If you want to do angle side, you have to pick the side that's the smallest, the next smallest to work with. Does that make sense? So we have to use this and this for law of sines. If you switch back to law of sines, you have to work with the smaller angle because otherwise, because think about what I have right now. If I pick this, this, and this, do you agree that this is angle side? Or if I picked this one, I would still have angle side. So because what we're working with is angle side, if you pick the smaller one, you'll always get the acute triangle that could be formed. If you pick the bigger one, sometimes it works, but sometimes you end up with an obtuse triangle and it ends up not giving you the right answer. So if you don't want to have to do law of sines ever, say the wrong one. If you don't want to have to do law of cosines again, the trick is pick the small one. If you forget which one to pick, you just got to do law of cosines again. Law of cosines will always work. Law of sines, because we switch to angle side, it sometimes gives us the wrong answer. But if we pick this one, we'll get the right one, and we can say what? Sine of b over 16 equals sine of 55.8. See, when I print the notes, you just complain because you don't have enough room.
I have enough.
Right smaller. When you do law of cosines and then switch to law of sines, make sure you type the right one in your calculator. It's really easy to type the wrong one. I do the wrong calculator. And again, this is what sine of b equals, so we have to do inverse sine, right? So this is where if you want to write all these decimals down, or you could just type inverse sine to begin with. 55138,705. 8705. I got angle B to equal 33.5 degrees. And then to find angle C, should we do law of sines again?
No.
Just add them.
I could just subtract 180, right? If you would get the same answer if you did law of sines again. Or law of cosines. It's your choice. But I'm just going to subtract 180. I got 90.7. Man, that was almost the right triangle.
So close to right.
So close, yet so far away.
It's not that far.
Okay, let's do that one. I'm just excited. That's actually the worst one. When they give you three sides, I think it's worse because you have to do all the algebra. I think it's much easier when they give you an angle because then you don't have to move this. There's a lot of notes today. That's why I printed them.
Thank you for bringing them.
That's why we couldn't have homework quiz. There wasn't enough time.
I guess just really thinking the opposite. That's side angle side.
It is. That's not side angle.
No, it's side angle side.
I know.
Yeah.
Okay. I thought you were saying something like, I thought there was something else after that.
No.
That's side angle side. So, like I was waiting for the.
Oh, so.
Can you do law of sines with this?
Nope.
Because the only angle they give you, you don't know the side across from it, and the sides they give you, you don't know the angle. So law of sines only works if you have a side and an angle together. So this is another example, the other example where we do law of cosines. There's just two. One is where they give you all three sides. The other one is when they give you side, angle, side. So which one should we solve for? Which one do we have to solve for?
That one.
We have to solve for side B, because you have to use the angle they give you. So that's where we can say b squared equals a squared plus c squared minus 2ac cosine of big B. And really we're trying to solve for b, so if you wanted to, they always write it like this, but if you wanted to save a step, you could really just say b equals the square root of all of this, right? I won't say that, but you could.
You already said it. You can't say
I mean, I won't write it yet. The nice part about this one is you really just type it on your calculator. You don't have to move stuff over. So a is 15, so 15 squared plus 42 squared minus 2 times 42 times cosine of 49 degrees.
Heck, I get 50.
And you can just type all that in at once. And you could just take the square root of all of it. Right? You don't have to do any algebra. Just punch. How does my 2-year-old know what it means to punch? Last night I said something about punching and he goes, he punched me in the arm. I blame daycare.
Watch a lot of action movies.
No, just watch SpongeBob.
I don't get punched one SpongeBob. He does karate.
He does karate.
Karate.
That's what b squared equals, so I just was saying if you wanted to just save that step to begin with, really at this step, you could type the square root of all this in your calculator and you would get the answer in one step. One calculator step. I got b to equal 34.1. Did you get that?
I sure did.
And again, just like the other problems, we could do law of cosines again, but we also can do law of sines. Can we do law of sines now?
Yeah, use the little one.
Use a little one. So I can say sine of A over 15 equals sine of 49 over 34.1. Oh, I don't. The new SpongeBob movie. I haven't either. My son wanted to go watch it, but we didn't.
You should take it.
Well, because I have a 2-year-old that I don't think would sit still for a movie.
Then put the cereal parking lot. Car. Crack the window. Yeah.
But there's a new Minion movie gonna come out this summer.
That's a lot.
Yeah, I think it's called Minions. I don't even know really.
Yeah, it's just called Minions. Fuck yellow guys.
But he loves Despicable Me, and so I think that's gonna be the first movie we take the 2-year-old to.
That's a great movie.
We watch it all the time, Despicable Me.
You got Despicable Me too? That's a good one too.
We do.
We have both of them. My dad loves the Minions more than the rest of it.
19.4. And then angle C, we're just gonna subtract from 180. I feel like this test is gonna take us like 17 days to take. 126.5. Okay, whew. What else can we do? That is not right. You know what I did? I subtracted 34.1 instead of 49. 96.9. Is that right? What did you get? Oh my gosh, I'm still doing it wrong. Never mind. I'm with you kids. I really know what I'm doing.
111. You're in radio mode, aren't you?
No, I was subtracting this, and it's a side, not an angle. Like I took 180 minus this minus this. I'm getting hurry. What else is in this section? Some story problems. Also some area formulas.
I know what the area of a triangle is.
Normally, when we have a right triangle, right? When did you learn this formula? Hopefully a long, long time ago. 1/2 base times height, because a triangle is really just half of a square, right? That's why it's half of the base times height. Because if you've made 2 triangles, you get a square. Did you know that? We could prove that. If that's
I actually didn't even know that until now.
That's true. That's why that's the formula. But the issue is when you don't have a right triangle, you have to worry about what the height is. And if I gave you an oblique triangle, you could draw the height in, and we could use some trig, and we could always figure out what the height is. But there's a formula that if you just have an oblique triangle, A, B, C, that if you take half of any 2 sides times the sine of the included angle, that will always be the area. Is this something you're going to remember on a daily basis? Probably not, but it is true. So like if you wanted to use side B and C, then you have to use the angle that's in between it. So you have to use like side, angle, side. So you take half, that's what the first one is, half of the 2 sides and the sine of the included angle. The cool thing is, on the problems like this, they usually only give you one angle and two sides, so you just put them together. But it works for any of them, right? So let's just do one. Ready? Every year on the test, I give one of these questions, and people forget the formula, and they just draw the height in, right? Because if you didn't know this formula, you'd have to draw the height in, and if you knew an angle, then you can, and you knew a side, then you could just do trig and you could figure out the height. Does that make sense?
Yes.
Yeah, as long as you get the right answer. This is just supposed to be a
We
quick
just
way.
measure the ruler
So
instead.
we have to know this one.
Yeah.
To measure with the ruler instead.
No. Because it's not drawn to scale. Because it's going to just be like this, right?
What keeps the scale
Correctly, that's going to be rough.
Do you have a prototype? Because that sure would help. I'll use that pirate hat thing you got.
You don't even really have to draw the picture here. But using that formula, it's 1/2 times the two sides times the sine of the included angle. And that gives you the area without having to draw the height in. I don't know that I've ever used this outside of this class.
I never use anything outside of this class.
I know, you're still a youngin. Sine of 120, I could make it give me an exact answer here, right? The sine of 120 is like square root of 3/2.
Yeah, we're not quite like that at all.
649.5 square units.
Not get that at all.
Oh, children.
Do it again. I think you messed up.
692.8.
That's much better.
What is today?
Calculator, what's wrong with you?
I put 30 into the 32. I just typed in the wrong thing. That's why I hate calculator stuff, because you just type in the wrong stuff all the time.
Don't take the cane and give it later.
That's where on a test I would put a check mark here and then I would say wrong here and be like, what happened?
User error, not the calculator.
Wait, so that was it? That's it from the area?
That's it.
I like that one.
I like this one better.
I don't know about that.
But it's different. Like, it depends on what they give you. On this one, what if they only gave you the three sides of the triangle? If they only gave you the three sides of the triangle and they asked you to find the area of it, if it's not a right triangle, then it's another issue to find the height. Or you can use Heron's formula.
Carolyn?
Heron, H-E-R-O-N.
Drug?
No, like,
Heroin?
let me find it. There's a-
Like Lady Bird.
Heron.
That's the story.
Heron's formula is named after Heron of Alexandria, whose proof of the formula is the oldest on record.
Did you also no relation to drugs whatsoever?
So again, the nice thing is if you don't have the height, if it's not a right triangle, then you struggle finding the area. But this formula, you have to find S is the issue.
Holy crap, that's long.
S is just the perimeter divided in half, yes? So
Same like perimeter.
the semi-perimeter, because it's half the perimeter. And if you find half the perimeter, all you do is you take the square root of half the perimeter times half of the perimeter minus each of the sides. I remember this formula much easier than I remember the other one, just because I was...
But we have to memorize this for the last one?
Probably.
Whoa. So you were going to make it more fun this time.
No, I mean the other ones. These are different. These are proof things. These are area formulas. Yes. So if I'm going to find the area of this, I'm going to take 31 plus 52 plus 28, and I'm going to divide it in half. As bad as I've been adding today, I better use my calculator.
35.5.
So then, to find the area, I'm just going to take the square root of 55.5 times 55.5 minus each side. So minus 31, 55.5 minus 52, 55.5
Oh my god.
minus 28. And I'm going to type that all in my calculator at once, including the square root sign, and I'm going to get the area. So yes, you have to memorize the formula, because otherwise, like, it's, if I gave you the formula, there's nothing even to do here. Like, that's just silly. But I went for you to tell the answer since I've been messing up all day. I got 358.1. Did you get that?
I got 661.
children, are you kidding me?
I got domain error.
What did you get?
360 something. Yeah.
What? Why did I not get that? 358. Oh my gosh.
361.8. I got 361.8.
361.8.
What'd you do?
I forgot this 0.5. I just had 55 minus 31.
You did.
I need help.
Check your work. We should probably just cancel the homework today. Do it at all.
This is really funny.
Just because I'm distracted doesn't mean you're distracted.
I am. That's basically. Oh.
It is a baseball letter.
361.
Is it finish square really?
Or not.
I think the center of the rubber is 25. I was gonna say I was maybe like 60 flat. Maybe it's 60.5.
We did this question in Math 137, and Mr. Love disagreed with this as well as the class, and we went out to the baseball field and we measured, and I was right. This is right. So
You're exactly right. Like 2 tenths of an inch.
I'm just saying. He said, Mr. Love said that the pitcher's mound should form a right angle with this,
See, I don't agree with
which
that.
is not true because it's not centered. Like the pitcher's mound is not centered in the middle. It's up a little bit, right?
No, it's back a little bit. Yeah.
Back a little bit.
Yeah. It's
Whatever.
first base is not crazy.
Anyway, it's not a right angle. I don't really care what it is. But they tell us that the pitcher's mound is 60 and a half feet from home plate. 60.5 feet. And 90 feet between each base, right? How far is the pitcher's mound to third base? My students tried to tell me that this was the right angle and that we could just do SOHCAHTOA or that this should be the same. And I disagreed. So we went out to the baseball field with Mr. Love and we had this little string. We didn't really measure the feet, but we had string and we measured from home plate to the mound and then checked to see if from the mound to third base was the same, and it's not. It's further away.
Yeah, but after all your measurements today, who really knows how accurate you are?
Yeah, it's fun. And then I was right, and then we come inside, and then he takes all the credit. He's like, I told you. This is why I hate you, Mr. Love. I won.
Classic Mr. Love. I would do that too, you know.
You're on this road.
And I knew I was right because I knew we shouldn't be using SOHCAHTOA here. But what we can say is from home plate to here, this is a right angle, yes?
Yes, that's
And if I go straight, like the home plate is centered to the pitcher's mound,
half a right angle.
that should be 45 degrees. That's what we can say. We can't say we know this is 90 degrees, because it's not. And what are we trying to find? This side, right? How far from the pitcher's mound to here? Can I use law of sines here?
Yes. Nah, you guys love those signs. Basically.
Because I don't know a side and an angle, right? This one's not going to be exactly 45 degrees. So I think I need to say like x squared equals 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45. Or we could just go out to the
I
baseball
think
field
it'd
and
be
measure.
faster just go measure, yeah.
I don't know, I think by the time you went and got the measuring tape, I'd be done. Because I'm almost done.
You probably have to redo it.
If I can type it in correctly, let's see.
But it would have to already know something.
Yeah. Well, first, Mr. Love tried to say his baseball field was just built wrong. Like, that was his first defense when I was right and he was wrong.
Our baseball field.
Well, my baseball field's probably just wrong.
Yeah. What did it say, right?
So then he's Googling it to see if he's right.
And it wasn't.
He wasn't right.
Yeah.
All right, let's see if I did this right. 4059.857153, and then we would take the square root of that. which is 63.7-ish, a little bit further away. What Mr. Love did, here's why he took all the credit. Because he's like, okay, each side's 90 feet. My Mr. Love voice. Each side's 90 feet. So if we draw this
That's
in,
not his voice.
Yes, it is. Keep going.
if we draw in from here to here, if this is 90 feet and this is 90 feet, how much is this? And I was like, 90 squared root of 2, because being the math person I am, I was like, it's a 45, 45, 90 triangle. And he's like, what is that? 90 squared root of 2? And I was like, I don't know, I need a calculator, I can't multiply that in my head. So then I said, it's 127.28. I said, so see, it's not in the center because this doesn't add up. And he's like, yeah, that's what I'm saying. It's not in the center because it doesn't add up.
How long ago was this?
Like 2 weeks ago.
Oh, so it's like recent.
Yes, like my math.
Why have we never heard
Yeah,
about
why don't you
that?
tell
It
us
was
that?
right before spring break, so that's why.
I'm gonna tell him this.
You can tell him my voice that I use for it. He's like, so see, I told you. Why don't we just do this? And I'm like, I was trying to prove to you I was right. I could have done this too, but he was just he took credit for this, that this was the whole. I should send him this recording of me talking to Jackie about it.
Baseball time is built wrong.
Man, that looks like a long problem.
It's 12, already counted. Please 11.5.
Okay, so maybe we should emphasize something really quickly here. How much time do we have here?
Less than 9.5.
Do you know the rule of how do you know if 3 sides can make a triangle? Do you know that?
They all connect.
But what if you don't want to draw it out?
Right, one, that's the sum, the 2 and 4.
All you do is just stop.
What if I gave you these 3 sides of a triangle? If I said, find all the missing sides, 1, 2, 3.
Those are all the sides already there. It's like a line. But you need to think through something.
It doesn't really work because if two sides add up to not be bigger than the third side, it's not going to make a triangle. Does that make sense what I'm saying? Like think of our favorite triangle, my favorite triangle, a 3, 4, 5 triangle. Do you agree that in a 3, 4, 5 triangle, if you take any 2 sides and add them together, it's always bigger than the third side?
Yep.
If that doesn't work, you can't make a triangle. There are at least 2 questions on this homework. Okay, maybe. There's at least one. Maybe there's another one. Then it doesn't work, and if you try to work it out, you'll end up getting that it doesn't work, like you'll have a problem. But if you recognize right away, 1 plus 2 is not bigger than 3, you can just say doesn't make a triangle, and you don't have to do any work on that problem. Doesn't form a triangle. Okay, so that's kind of some weird stuff. I think it's dumb that they even give you those, because why do they give you something that doesn't make a triangle? So, just checking here. Okay? Okay, I'll be fine. And then some of these are just area. The area ones go pretty quickly, right? Like 18 is area, 19 is area, 21 is area, 24, 27. Then there's one about baseball field. Football kick, oh my goodness.
Football kick.
Another area. Seven of these are about areas. So that's not so bad.
Maybe it's 5 of them are.